Hi, Mr. Beeb, sir. This is my trigonometry thinking project on the monthly average temperature of Phoenix, USA in degrees Celsius. So the first step was I had to make a scatter plot by plotting the data points for each month. I set the scale on the x-axis using the numbers from 1 to 12, as each numerical value represents the month of the year in order from January to December, of m equals 1 representing January, and m equals 12 representing December. So next, using the scatter plot, I had to determine an equation of the cosine function that would represent the data. But as you can see, the curve of the best fit doesn't represent the data too accurately. Other than the min and max points and the first three consecutive points, all the other points are not closely along the curve, thereby misrepresenting the data. So that's why I decided to adjust the equation. So I knew I had to horizontally shift the graph to the right so it could align with the points on the far right, which is why I increased the d value. That I knew the graph was compressed, so I had to expand it so that the curve can closely touch the points along the edges. So I decreased the value of k. Finally, I increased the vertical shift by 0.1 so that the curve would be a little closer to the points at the top right. So as you can see, this modified graph more accurately depicts the data. So now using this modified equation, I had to algebraically calculate the average temperature of Phoenix in mid-April. So mid-April equates to m equals 4.5. So I subbed in the value of 4.5 into the algebraic equation to get a value of 25.6 degrees Celsius. And to verify this using a graph, I went to 4.5 as m value, and saw that it equals to a y value of t value of 25.6 degrees Celsius. And the next part of the step was I had to determine another um, point in time where it also averages 25.6 degrees Celsius. So I went across the graph and I found out that the value of m value of 9.8 equals 25.6 degrees Celsius, and 9.8 is approximately late September. So I subbed in the value of m equals 9.8 into the equation to algebraically verify this, and I got 25.6 degrees Celsius. And now the last part of the problem is the average monthly temperature pattern actually does make sense because Phoenix is located in the northern hemisphere, as most countries in the northern hemisphere are known for having below average temperatures during the first few months of the year and last few months of the year, and above average temperatures in the middle set of months. And that is why my graph starts at a min, it goes to a max, and ends at a min. Thank you for listening to my video. I hope you enjoyed.